So our next unit is going to be on area. At this point, the things that we have to cover after trigonometry will be area. Then we'll be doing three-dimensional figures, volume and surface area. And then we'll be doing a whole bunch of things with circles, and then there's one little bit at the end in addition to that. So that's kind of where we are in terms of the rest of the year. So just a couple of reminders. First of all, the area of a two-dimensional figure is a measure of the amount of surface the figure has. The units of area are always square units, square feet, square centimeters, etc. Why is that? Well, the way that we calculate area is to say, if we say that it was 50 square feet, we're saying that it would take 50 squares, 1 foot on a side, to exactly cover the object. That's what we're doing. So to cover something, you need something that has 2 dimensions. And we choose squares. Now, could we have chosen something else? Yes. You could have chosen hexagons and said, well, it would take this many hexagons to cover it. But it's way more complicated, honestly. Right? With squares, you can fill things more easily. All right. A reminder, any side of a parallelogram can be designated as the base. It doesn't have to be what's on bottom. Most of the time we do use what's on bottom, but sometimes it's better to use what's on the side as the base. The corresponding height must be perpendicular to the base and connect to the opposite vertex or opposite side. So, for a parallelogram, the area of a parallelogram with base B and height h is given by the formula area is equal to base times height. Why is that? Well, that's because if you were to cut this little piece over here off and then tape it on over here, you'd have a rectangle whose base would be B and whose height would be h. If you took how many squares it took to go across times how many squares it took to get to the top, that would be how many squares it would take. So that's where this formula comes from. Again, the base doesn't have to be on bottom, it can be on the side. In most cases, the base is going to be on the bottom, but not always. So, let's take a look at this one. Here we want to find the area. So the area, I strongly suggest, I don't absolutely require it, but I strongly suggest that you write out the formulas as you use them. I do require that you show me what it is that you're multiplying together. Yes, I know you have a calculator for this, but I want to see what you're multiplying so that I can give you partial credit if something goes wrong. The problem that I have with this is I don't know the height yet, but we should be able to find that pretty quickly. What is the height going to be here?
8.
Yeah, it's going to be 8 centimeters. So that's 96 square centimeters. All right, let's add some. Now, realistically, this is a junior high problem. Maybe a little bit more because you had to do the Pythagorean theorem to find the height, but not much more. To make it more of a high school problem, we have ones like this. Find the height of a rectangle in which the area is 6x squared plus 24x minus 15 square inches if the base is 3 inches. So we've got area is equal to base times height. So the area, which is 6x squared plus 24x minus 15 square inches, is equal to the base, which is 3 inches, times the height. Simply going to divide both sides by 3 inches. 6x squared divided by 3 is 2x squared. 24x divided by 3 is 8x. And negative 15 divided by 3 is negative 5. Then the units, inches squared divided by inches, is inches. All right, let's try another one. Find the perimeter of a rectangle if one of its sides is 6 feet and its area is 12x plus 18 square feet. Well, we know that the area for any parallelogram, and that includes rectangles, is base times height. So that's 12x plus 18 square feet is equal to, I can use any side I want to as the base, and the other side will be the height. So that'll be 6 feet times the height. Divide both sides by 6 feet. And we get 2x plus 3 feet is the height. So what we have then is that the base is 6, the opposite side will also be 6, and the height will be 2x plus 3. So if we're doing the perimeter, we simply need to add all those together. Gathering the like terms, bless you, that'll be 18 plus 4x feet. All right, now let's talk about triangles. So the area of a triangle with base b and height h is given by 1/2 base times height. Where'd the 1/2 come from? Anyone have any idea at all? Yes? Well, not always half of a rectangle, but always half of a parallelogram. Yeah. If you copied and pasted that triangle on here, you'd have a parallelogram. We just have half of that. So that's why it's half base times height. In a right triangle, we can use the legs as the base and the height. And sometimes the height will be outside of the figure. Okay, if you have an obtuse triangle, that can happen. So let's try this one. Find the area of the triangle. At this point, we've got the height, but we don't have the base. How am I going to find the base? Yeah, Pythagorean theorem. And since I want to give exact answers, I'm going to want to cut those down. This is going to be 2 times x. 7 squared plus x squared is equal to 10 squared. 49 plus x squared is 100. So x is the square root of 51. So the base is 2 square roots of 51. So the area, 1/2 base times height. So it'll be 1/2 of 2 square roots of 51 times 14. If I just multiply, 1/2 times 2 is 1, times 14 is 14. So I get 14 square roots of 51 square meters. Okay, any questions about that? So we're just adding some of the things that you already know to some algebra that you didn't know when you first learned all the area formulas and going from there. One more on a triangle. Find the base of a triangle in which the area is 15x squared square centimeters if the height to that base is 5x centimeters. All right, so the area is 1/2 base times height. Filling in what we know, the area is 15x squared square centimeters equals half times the base is 5x times the height. Oh, excuse me, my fault. Wasn't paying attention to which was given. They want us to find the base, and the height is 5x. Lots of ways you can do this. I think the easiest thing is to multiply both sides by 2 to get rid of the half. So that'd be 30x squared square centimeters is equal to the base times 5x centimeters. Divide both sides by 5x centimeters. And we get 6x centimeters is the length of the base. All right, then we'll also look at trapezoids. The area of a trapezoid is equal to 1/2 the sum of the two bases times the height. And you're like, that seems like an unnecessarily complicated formula. But if we think about a trapezoid, there's actually multiple ways you can think about this. But if you remember the mid-segment, which was half the sum of the two bases, right? If you draw the mid-segment in any trapezoid, you can do this. You can cut this piece off, stick it right there, cut this piece off, stick it right there, and we get a rectangle whose base is equal to the mid-segment, half base 1 plus base 2, and whose height is the height of the original trapezoid. So that's why that formula works that way. That's one way to think about it. There are actually several others, but that'll do. So here we want to find the area of this trapezoid. We know that the area is equal to 1/2 the sum of the two bases times the height. We quickly realize we don't have the height. So I'm going to drop in an altitude on both sides, which creates a rectangle in the middle and two 30, 60, 90 triangles on the ends. We know that this middle part of the lower base is 14. 14 from 22 leaves 8, and these two triangles are congruent to one another. So that means each of these pieces is 4. So what is my height going to be then?
4 squared of 3.
Yeah, 4 squared roots of 3. So it's going to be half of 14 plus 22 times 4 squared roots of 3. So that's half of 36 times 4 squared roots of 3. And although you can use a calculator for that, because you're going to have a calculator because there's going to be some trig on this next, area test, you can do this by hand pretty quickly if instead of taking half of the 36, take half of the 4. Half of 4 is 2, and 2 times 36 is 72. And since there were no units given in the problem, we don't have to put units in our answer. Well, let's turn this one around. This time we've got a trapezoid, but they give us the area. They give us one of the bases and the height, find the length of the other base. So this is an algebra problem once you get everything substituted in. So the area is 1/2 of base 1 plus base 2 times the height. Let's make this 230. I think I meant to change that and did not. I think if we don't, it becomes unnecessarily ugly. So that's 230 is equal to half. One of the bases is 11. I don't know the other base. I know that the height is 23. Since taking half of 23 isn't very nice, I'll go ahead and multiply both sides by 2. That'll be 460 is equal to the quantity 11 plus base 2 times 23. You could have divided by 23 to start with, because that would have gone nicely. Dividing, though, you get 20 is 11 plus base 2. So base 2 is 9 millimeters. Questions about that? Okay. Up until now, all these formulas are formulas you learned in middle school or maybe even earlier in some cases. This last one is a new one for you. Therefore, it's the one that students tend to forget because it's brand new. So, for kites and rhombuses, it turns out that the area of any quadrilateral with perpendicular diagonals, D1 and D2, is given by 1/2 D1 times D2. The reason for that is not immediately obvious, but if we go to this diagram for just a second, if I cut this in half, the area of the triangle over here on the left, if this is D1, this would be half of D1 times half of D2 because it's only half the distance. But then I would need to double that, so I ended up with just half of D1 times D2. So, find the area of a rhombus with diagonals given here. So the area is 1/2 diagonal 1 times diagonal 2. So it's going to be half of 8x plus 7 centimeters times 14x minus 6 centimeters. Since taking half of 8x plus 7 gives me a decimal or a fraction, I'm going to take half of the 14x minus 6 instead, because when I multiply things, the order doesn't matter. So I'm going to say that this is equal to 8x plus 7 centimeters times 7x minus 3 centimeters. Your choices are you can do that or you could multiply these two together first and then take half. I choose to take half first because it makes the numbers smaller. Now I get to use the distributive property, or you may have called it FOIL. Ugh. 8x times 7x is 56x squared. 8x times negative 3 is negative 24x. Then distribute the 4. 7 times 7x is 49x. And 7 times negative 3 is negative 21. And centimeters times centimeters is square centimeters. All that's left for me to do is group the like terms. 56x squared plus 25x minus 21 square centimeters. One last one here. And I apologize, it's not immediately obvious, but the 28 is just from here to here. If I wanted it to be all the way across, I need to show you that it's all the way across. So when you have a measurement on a diagram, it's from point to point, not it's this whole thing, unless it somehow indicates that. So it tells us that this is a kite, which means these diagonals are perpendicular to one another. So I can use the Pythagorean theorem to find this little piece right here And since I'm interested in exact answers, I'm going to go, okay, what are both of these divisible by? 7. This is 7 times 4, and this is 7 times 5. So x is going to be 7 times 3, which is 21. Now I can use the Pythagorean theorem on this little triangle up here at the top. I can't call this piece x, I'll call it y. So I'll have 21 squared plus y squared is 29 squared. 21 squared, I know that one, it's 441. 29 squared, I don't know that one. It ends in a 1, but that's all I remember. $841. Oh, isn't that nice? Because when you subtract, you get y squared is 400. So y is 20. So now the area is 1/2 diagonal 1 times diagonal 2. What's the length of the horizontal diagonal? 42. And how long is the vertical diagonal? 48. So that's going to be 21 times 48. Ooh, see if I can do that in my head. 960 plus 48 is 1,008. Whew. And that'll be square inches. Just one quick thing to mention on this one. Let's say that this didn't come out to be so nice. You don't need to write this down, but do watch because this is going to come up. Let's say that this came out to be 10 square roots of 3. So when you're doing your area, it'd be 1/2 of 42 times this. You can't combine those. You'd have to say that it's 20 plus 10 square roots of 3. So then you would do 21 times 20 plus 10 square roots of 3, and you would distribute the 21. Okay? All right. Your assignment is in the book. And then also remember that you have a quiz on trig tomorrow. I'll look up about those problems.